guys, welcome to another video of chemical process calculation. Today I have taken an example of 2-unit process. So here is the question. A labeled flow chart of a continuous steady state 2-unit process is as shown. Each stream contains two components A and B in different proportions. Three streams whose flow rates compositions are not known are labeled 1, 2 and 3. Find unknowns 1, 2 and 3 streams. So I would recommend you guys to pause the video and try the question by yourself. Okay, if you have went through the question, this is not a single process, of course. Here are the 2 units. Let me show. This is one unit, this is other unit, and in between this is a mixing point. This is where another stream comes here, and a stream from M1 goes here. Another stream from outside comes. This is a mixing point. Okay. The first and foremost thing, we do degree of freedom analysis. So degree of freedom analysis here, as it is a 2-unit process and a mixing point, we need to choose the system. So choosing the system would be like, if I do a overall like this could be one possibility, and doing this as, okay, I denote this 1, this is 2, this is mixing point. Okay, for overally, if we see the degree of freedom analysis, as you can see, it is 0, it's solvable. And how it's 0? You see the overally how many flow rates are here. Like this is one input stream, this is output from the overall, and this is one more output, and this is one input. Yeah. So the unknowns are only two unknowns, M3 dot and X3, and correspondingly two material balance can be written. So 2 minus 2, 0, it's solvable. And if you do a degree of freedom analysis on this system 1, this one unknown is M1 dot and X1, even two unknowns and two balance equation, it is also solvable. Similarly, for mixing point, if we try, the mixing point has, you can see 4 unknowns as M1 dot X1, M2 dot X2, and the corresponding balance would be, corresponding degree of freedom would be 4 minus 2, it's 2. It's not solvable. We need two more equations. We need 2 more equations to solve that unit. So a mixing point, obviously we can't start from mixing point. Can we start from system 2? We see system 2 has similarly system 2 has 4 unknowns, M2 dot X2, M3 dot X3, and correspondingly 2 balances. So 4 minus 2, 2, it's not solvable. We can solve either from 1 or overall process. Overall, here I denote this overall, or from this one, considering this as a system. So let's solve considering the overall system. I did the degree of freedom analysis, it is 0. I do the total mass balance. You see total mass balance, we get M3 from here. M3 is solved. Similarly, we do A or B, whatever balance you want to do. We find X3 correspondingly. Then we do a degree of freedom analysis on system 1. We already did. It comes out to be 0. So we do similar thing. Total mass balance. Total mass balance is nothing but input equals to output. We see input. You check out the problem, what is input and what is output. Input is 100, output is 40, and M1 dot. So from here we write the equation, we get M1 dot and we do A balance, we get x1. And last unknown is left. We do a degree of freedom analysis on mixing point. At this point, mixing point, it is solvable. How? Because we did from we first did a material balance overall system. We got m3 dot and x3. Then we do a material balance. We get m1 dot and x1. So for now, mixing point, it has only two unknowns, m2 dot and x2. We do that. Total mass balance, m2 is solved. Similarly, we do A balance. You can also do A B balance, it doesn't matter. We get x2. So this is the question.